Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so today we are going to start a new chapter, and it is related to pressure in fluids and a little bit of concept of atmospheric pressure. So take out your pen and copies, okay, and start taking notes, because it is very essential that besides studying or reading, when you are studying, reading is not the only thing that you must be doing. You must also be writing simultaneously to improve your skills or to get a better understanding of the subject. Okay, it is very essential that you write as well as read. Okay, so reading and writing are both very important. Okay, so with this, let us start our chapter. So today we are going to start pressure in fluids. Okay, so just let me write it as pressure in fluids. Okay, so first of all, pressure in fluids and atmospheric pressure. Okay, so it's a little part atmospheric pressure, so we are not writing it in the heading. Okay, so first of all, before discussing anything on pressure in fluids, let us first discuss what is actually pressure. Okay, let us first discuss what is actually pressure. Fine. So see, pressure, so before discussing pressure, we have to first of all think of what is actually thrust. Okay, so all you have learned in the previous chapter when you have read about Newton's laws of motion, all you have learned what is force. So I think by now the definition of force is very clear to all of you. Now, if we consider a surface and we are applying a force, that force can be applied in many ways. Okay, so for example, let us consider a surface. So say this is a surface. Okay, this is a surface. Now you can actually apply the force in various ways. Like this, you can apply a force. You can apply a force like this. You can apply a force like this, or you can apply a force exactly perpendicular like this. Okay, so there are various ways by which you can apply the force. Okay, now force, you know, is that external cause which is leading to a change in the state of the object. It may be state of rest, state of motion, direction of motion, shape, size, anything. Okay, so it's leading to a change in the state of the object. Now, so that is the definition of force. Okay, now so force we can write it as an external factor that changes the state of an object. So this is the definition of force. Okay, now when you are talking of thrust, basically what is thrust? Okay, so when you are talking of thrust, what is actually thrust? So thrust is basically a special case of force. That is why we are denoting it by an arrow. Thrust is actually a special case of force. Now what is thrust? See, these various forces that you have applied on the surface of the object, among this force that you have applied perpendicularly at an angle of 90 degrees with the surface, this force, okay, this force is basically regarded as thrust. So can you just think of what is thrust? Yes, definitely. Thrust is basically the force that is being applied, perpendicular to a surface. So basically thrust is that force which you are applying on a surface perpendicularly. Okay, or say you can also say it as normal. That is basically thrust. Okay, so as you all know, the SI unit of force is Newton, CGS unit is dyne, and the gravitational units of force are kgf and gf. In the same way, thrust also do have the same units, because thrust is nothing but a kind of force. Is the perpendicular force that you are applying on a certain surface area. Okay, fine. Now, so this is the basic definition of thrust. Now how can you actually, so when you think of, say you are keeping an object on a certain surface, okay, so when you are thinking that you have kept an object over this surface, let us draw the surface once again, okay. When you have kept a object, okay, so this is our surface, this is a tabletop, okay. Now when you have kept an object over this, okay, you have kept an object over this object definitely exerts a thrust on the table surface. Now can you guess what is the value of the thrust exerted, or what with which you can equate the thrust? It is basically, you can say that the weight of this object, okay, weight of this object acts as the thrust over this table surface, okay. When the object is kept over the table surface, the object has a certain weight, and that weight is basically exerting the thrust on the table surface or on the surface on which you have kept the object, okay. So this is the basic concept, try to understand it. Now in case of solid objects, this weight is always acting downward, so obviously thrust is always acting downward perpendicular to the surface on which it is kept. Fine. Okay. Now, so you have learned that what is scalar and what is vector quantity. So can you say, when you are talking of thrust, what kind of quantity is it? Is it a scalar quantity or a vector quantity? See, I think you have remembered the definitions of scalar and vector quantity. From that definition, can you say that thrust, as it is exerted due to the weight of the object acts vertically downward towards the center part. So definitely thrust will also be acting vertically downwards towards the center of earth, isn't it? Thrust will also be acting vertically downwards towards the center of the earth. So definitely thrust has a definite direction, isn't it? Thrust has a definite direction, and this property, that when you are saying that yes, thrust has a definite direction, this property is actually indicating that thrust, like force, is also a vector quantity. Force is also a vector quantity, because whenever you are talking of applying a certain force, it is always in a certain direction. You need to specify the direction in which way you are wanting to apply the force. So obviously when you are talking of force, it's basically in a certain direction. So force is a vector quantity. Likewise, thrust is also a vector quantity. Okay, fine. So these are the things that you need to remember while understanding the concept of thrust. Okay. Now, so how can we define pressure? So I think the concept of thrust is clear. Now next is, how can we define pressure, or what is actually pressure? So obviously pressure is also a physical quantity. Now imagine of it like this, that when you are considering the effect of thrust, okay, when you are considering the effect of thrust, say a thrust of, consider a thrust of 10 Newton, okay. You consider, so there are two surfaces, one is like this, okay, this surface, and this is a small surface like this, not big, it's small surface, okay. Now this surface has an area of A1, this surface has an area of A2. Now A1 is greater than A2. Now you are applying the similar kind of force, so rather say it to be thrust. We are applying a thrust of say 10 Newton on this surface, and also a similar thrust of 10 Newton on this surface. So do you think that the impact of this thrust on these two surface areas will be same? If you try to just think it of logically, the impact of these two thrusts on these two surface areas will be different, as because simply the surface areas are not the same. The surface areas are different, so obviously the thrust act will also differently. Impact will be different. Okay. Now, so in order to actually justify, or in order to quantify the impact, that is, you want to compare it in exact terms, in exact numerical values, a physical quantity was introduced, and that is known as pressure. So basically pressure is a physical quantity which is trying to help us to understand the impact of the thrust on a certain area. So for that, what we have done, whenever we are thinking of the impact, okay, what we tend to do, we tend to consider the quantities in unit amount, okay. So if we think that when you are trying to ascertain the impact of the thrust, okay, so what you will do, you will be actually considering the unit values. So if we think of that, what is the thrust impacting on unit area, okay, thrust impacting on unit area, that gives us the concept of pressure. So basically we can define pressure as, so pressure is nothing but it is the thrust acting per unit area. So thrust by the area upon which is acting is the mathematical definition for pressure. Okay, fine. So this is pressure. Now thrust, as you know, has an SI unit of Newton, area has an SI unit of meter square. Okay, so can we say that the SI unit of pressure is Newton per meter square, n m to the minus 2, and this quantity, this unit is in short regarded as Pascal, PASCAL. In short, it is written as capital P small a, Pascal, PA. Okay, so this is the SI unit of pressure. You can also consider that if the force or the thrust is taken in a unit of say dyne and it is in centimeter square, so that can be also another unit of pressure, dyne per centimeter square. Or if maybe the thrust is exerted in terms of the kgf, then kgf per meter square can also be another unit of pressure, or gf per centimeter square can also be another unit of pressure. So there are various units, but the most commonly used unit is Pascal. There is another unit which we will be discussing it later when we will be talking of atmospheric pressure. So then we will be actually learning of another unit that is being used, and that unit is basically atmosphere. Okay, we will see how atmosphere and Pascal, these two units are related to each other. Fine. So this is the concept of pressure. So can you imagine that pressure basically depends on two factors. One is the thrust applied, more the thrust, more the pressure. Other one is the area, more the area, lesser is the pressure, lesser is the area, more is the pressure. As because pressure and area are inversely related, whereas pressure and thrust are directly related. So these are the two factors which affect the value of pressure at a certain area, on a certain area. Okay, fine. Okay, now just we want to talk of another definition. So can you, from this mathematical relation, can we define the unit Pascal? Yes, obviously we can. We have learned that if you want to define any unit, any derived unit, we have to first of all understand the formula. So the pressure is having the mathematical formula of thrust by area. So if I consider how can we define 1 Pascal? So can I say that the quantity 1 Pascal will appear on the left hand side if both the thrust is 1 Newton and area is 1 meter square, isn't it? So if it is 1 Newton per meter square, then it is basically 1 Pascal. So can we define Pascal like this, that 1 Pascal is that pressure which a force of 1 Newton exerts on a surface area of 1 meter square. So this is basically the definition of 1 Pascal. Is the pressure which is exerted by a force of 1 Newton on an area of 1 meter square. Another thing that must be mentioned, this force is acting perpendicularly. So pressure which a force of 1 Newton exerts, we have missed one word, exerts perpendicularly or exerts normally, okay, on a surface area of 1 meter square. So this is the definition of 1 Pascal. Okay. So I think the definition is clear. Fine. Okay. So with this we have come to the conclusion of this lecture. We will be discussing more about pressure on the next lecture. We will be doing some small numerical problems. Okay. So till then, please do study well. If you have any query, mention it in the comment box. We will be happy to solve your problem. Okay. Thank you. Goodbye.